In a transitioning world where renewable energy is a buzzword along with carbon neutral and net zero, WA is keen to develop and export one such renewable energy, hydrogen. That's right, hydrogen, position 1 on the periodic table, is the molecule that is the crucial ingredient in the sun and undergoes nuclear fusion to produce the light energy that is needed here on Earth to drive our climate and the critical photosynthesis reaction that sustains our lives. Hydrogen is the most abundant element in the universe. It is the lightest element and occurs as a simple molecule, one covalent bond between two hydrogen atoms. Simply take water and put it through electrolysis to produce the hydrogen molecule, making it a rich energy source. Hi, my name is Susie Urbanak. I love rocks and climbing volcanoes in my spare time, but I'm the core lead for the Core Learning Foundation when I'm working. I'm forever striving to align curriculum with the real world so that educators and their students can bring their curriculum to life, making it the real world. I call this CARMA, contextual, authentic, relevant, meaningful and applicable learning. It's also what I call STEM learning, the hands-on learning component that has students working on topics or a project that reflects their environment and what is going on in the world around them, and more importantly, how their learning applies to potential future careers. So in this video, it's all about a new industry. Potentially an industry that students may be employed in through the diversity of careers and jobs, some of which are presently unknown. In CORE, we pride ourselves on what we offer educators in terms of curriculum connections and our unique core learning model. We are a resource. We train, mentor, coach, support project-based learning and provide relevant and up-to-date information for project planning and delivery. If after this overview you would like to know more about what we do, contact us at info@corefoundation.com.au. So much can be said about hydrogen and its role as the world transitions into the 5th industrial revolution. It's already evident in our lives, much more than we may realise. Have you heard of a hydrogen-powered kitchen? As an avid watcher of cooking shows, I've learned that such a system uses hydrogen as its primary energy source. Another example is hydrogen-powered vehicles. Collaborating car companies are introducing hydrogen-powered domestic cars into Australia, aiming to create a hydrogen refuelling network to support the vehicle's voyage, including a 600-kilometre tank worth of hydrogen for travel. Hydrogen as a fuel is on the cusp of its evolutionary development. So why is Western Australia a good production, development and export environment for hydrogen? How can the awareness of its potential growth be communicated to students? And where in the curriculum can it be added to support student learning and connectedness to real-world problems? After all, the development of the hydrogen ecosystem, if approached correctly, is underpinned by the United Nations Sustainable Development Goals, aka UN SDG. Affordable and clean energy, 7, which can only be achieved through responsible consumption and production, 12. Industry, innovation and infrastructure, 9. Sustainable cities and communities, 11. And decent work and economic growth, 8. Through authentic STEM learning at CORE, the understanding of such a vast system is holistic in our project-based learning. And therefore, students are able to understand their learning through the lens of the UN SDGs, to recognise how their science, HASS, design and digital technology curriculums can relate and apply to this new burgeoning industry in Western Australia. Incorporation of the UN SDGs helps to understand the bigger picture and the purpose of the hydrogen sector, its position in WA, and its relevance to job opportunities and career diversity in support of economic prosperity for our state and ultimately our nation. So, where do we begin when it comes to understanding the hydrogen industry? Well, let me explain, and as I do so, how hydrogen correlates to the curriculum may also become apparent. The first thing to know is that physically, the Western Australian landscape has some of the world's best solar, wind, tidal and wave resources. This, together with 2.5 million square kilometres of landmass shared by just 2.6 million people, are critical ingredients for making renewable hydrogen energy. The northern regions of Western Australia, the Midwest, Gascoyne and Pilbara have the highest solar irradiance per square kilometre worldwide. The Midwest to the Great Southern have prevailing winds to generate the power needed to make hydrogen, and the 12,000 kilometre coastline provides the desalination of water required for electrolysis. In addition to the landscape, Western Australia is also one of the world's richest hotspots for mineral resources. We potentially have the critical and rare earth materials required to make the machines to make the hydrogen gas and used to transport hydrogen, and as a fuel source to power machines, such as electrolyzers, wind turbines, electric vehicles, and other decarbonised products such as green steel and green aluminium. This uniquely positions Western Australia to play a crucial role in servicing the entire renewable hydrogen supply chain. In 2026, Kalgoorlie, Western Australia will have its first rare earths refinery producing metals such as neodymium, dysprosium, praseodymium and terbium. Metals that are critical to make magnets for these electric engines and turbines. Let's dig a little deeper to see how hydrogen energy can be used to power an electric car, one made by collaborating international car manufacturing companies, and how it coincides with the hydrogen refuelling network in Australia. In the engine, hydrogen molecules are oxidised as they pass over a platinum catalyst. So the hydrogen loses its electron and becomes positively charged as the hydrogen proton. This oxidation reaction is exothermic, releasing heat energy. The hydrogen protons pass through a polymer membrane to the cathode. Simultaneously, the electrons pass from the anode, negative electrode, to the cathode, positive electrode, forming an electric current. The DC, direct current, is converted into AC, alternating current, to power the car. At the cathode, the hydrogen protons react with oxygen to produce water released from the car's exhaust. The car is a product at the end of the hydrogen energy value chain, as is the humble hydrogen kitchen I mentioned earlier. In the concept stage, electrical energy companies have combined their products to develop kitchenware such as hydrogen cooktops to explore the use of hydrogen to power them. For everyday use in cars and cooktops, hydrogen is lighter than air and will escape into the atmosphere quickly with reduced flammable risk. So we have the end members of this value chain, but how do you actually make hydrogen gas? The principles behind its manufacture are actually easy to explain. To start, we need renewable energy. Wind and solar or non-renewable energy such as the existing LNG electricity grid to desalinate water. This desalinated water is electrolysed into hydrogen and oxygen gases. This hydrogen gas can then be stored for transport along domestic pipelines for industry and domestic use, connected to hydrogen fuel ecosystems to power transport, exported to other Australian and overseas markets, or can also be converted to ammonia for export, where it will be converted back to hydrogen gas at its destination. Although the principles are simple, the realisation of this transition from manufacturing to delivery and its services is much more complex. It starts with a sustainable approach to the use of resources. For example, how water is used to explore and find the critical and rare earth minerals essential to manufacturing machines required to make hydrogen gas. The infrastructure development to produce, transport and export hydrogen, and the human resources needed to operate and manage this new technology and ecosystem. There is a lot to consider when writing a learning program to deliver the understanding and awareness of this potential new Western Australian industry. A fun fact, hydrogen is a rainbow. What does this mean? Well, there's green hydrogen made exclusively through renewable energy sources such as wind to power the electrolysis to make hydrogen gas. Purple hydrogen, which is produced through nuclear energy to power the electrolysis. Yellow hydrogen, which is again renewable but uses solar energy to power the electrolysis to make hydrogen gas. Turquoise hydrogen, which uses natural gas as an energy source to power pyrolysis to generate hydrogen gas and solid carbon as a byproduct. Blue hydrogen, derived from natural gas through the process of steam methane reforming, SMR, where a chemical reaction creates hydrogen and carbon dioxide. Carbon capture, utilisation and storage, CCUS, is used to prevent the release of carbon into the atmosphere. Carbon dioxide is its byproduct. Grey hydrogen, which is produced by superheated steam breaking down methane or other natural gases. Carbon dioxide is its byproduct. And lastly, black hydrogen, which uses brown or black coal as its primary reactant, utilising a process technically known as gasification. In layman's terms, it simply means burning the coal, and carbon dioxide is a byproduct. Just looking at this rainbow, the economics of its production are easily seen. To teach students and educators about hydrogen, I have written 2 core project-based learning projects, or PBLs as I like to call them, based on hydrogen energy and its use in future Australia. One PBL, called Pit to Port, is designed for primary school, and it looks at using hydrogen-powered trains to move the iron ore from pit to port across the Pilbara. These trains are the world's largest robots, and for some companies are remotely operated from Perth, some 1,800 kilometres away. Currently, they are diesel-powered. However, companies are working on hydrogen-powered alternatives for these huge tonnage long-haulage journeys. The other PBL, designed for secondary school, is called Feeding the Future Hydrogen Energy and focuses on using hydrogen to power agricultural machines in the wheat belt and, secondly, using hydrogen to make nitrogen-based fertilisers. For both PBLs, I've created a student and educator edition. The Educator Edition demonstrates the curriculum links to science and design and digital technology, with the scope to incorporate other learning areas through the STEM framework we use to develop our PBLs. In core, our mission is to support educators in transforming education through progressive teaching and real-world learning, and to broaden the opportunities for all students to succeed in STEM careers aligned with the needs of industries and economies of the future. This video reflects our mission as it provides an insight into one of the potential future industries of Western Australia and where STEM careers lie within them. It also serves as a reminder that whatever we do, we need resources, and these resources come from rock. There are essential industries for new economies, conceptual development and evolution. Delivering this real-world learning is something for which CORE has been recognised and awarded numerous accolades for. CORE's legacy is 20 years strong, and its learning model that utilises contexts like the hydrogen industry has proven to work. The CORE alumni, who are leaders in their STEM fields throughout Western Australia, are a testament to and validation of CORE's mission. This informative video creates an awareness of how our real-world learning model is essential for an emerging Western Australian hydrogen industry and can be easily integrated with the curriculum for fun student teaching. If you would like free help integrating a hydrogen PBL into your class or would like to get in touch, contact us via the link in the description. I'm only a video call or email away.